All right, today we're going to talk about ocean tides, specifically two called the neap and the spring tide. Most of you know that we have high tide and low tide every day. We actually have 4 tides every day, but we're going to be focusing today on specific ones called the spring and the neap tides. All right, make sure you have your notes out and you're ready to go, and we're going to be talking again about tides. Tides are the alternate rising and falling of the surface of the ocean. Okay, so that's a fancy way of saying sometimes it's high on the shore and sometimes it's not high on the shore. You've all probably gone to the beach and experienced that sometimes the water comes up really high and sometimes it doesn't. Those are called tides, and they change throughout the day. There's generally 2 tides and 2 high tides every day and 2 low tides. The tides are actually created by the gravitational pull of the moon and the sun on Earth. The moon, because it's a little bit closer, has a greater effect on the tide. So it's pulling a little stronger, again, just because the sun is a whole lot further away. So make sure you've got those notes filled out before you move on to the next. So as I said before, how many tides do we have in a day? Well, most places on Earth experience 2 high and 2 low tides. Some places don't, but again, most places do. So you'd have a low and then a high and then a low and then a high. And those change day to day. So it's not like at 12 o'clock every day you have a high tide and at 4 o'clock every day you have a low tide. Those change. And again, those are based on how the moon is, how close it is, what phase it's in, how hard it's pulling, all of those things. A couple fun facts about the Earth. High tide is always occurring in 2 places on Earth at the same time. And low tide is always occurring on 2 places too. So they're kind of opposites. If it's occurring here, straight across the other side of the Earth, they're also having a high tide. If we're having low tide here, again, straight across the other side of the Earth, we'd be having a low tide. The moon's gravity pulls on the Earth's surface, but since the water is a liquid, it kind of stretches. Our ground can't stretch, but the water can sort of stretch and move more than the Earth's surface, and that's why we have the tides. The gravity from the moon stretches the water, causing it to pile up in what we call a tidal bulge. Again, a bulge is kind of where it sticks out. So the water sticks out more onto the shore sometimes than it does other times. You can see from the pictures, sometimes the tidal change is pretty dramatic, as in the pictures on the right, and sometimes it's a little less dramatic, as the pictures on the left. Our tides are always changing. The water's going in, the water's coming out. The water's going in, the water's coming out. Here's another great example of a pretty extreme tide. So this area is almost completely covered in water during a high tide, but during a low tide, you could almost walk on it. It'd be really, really mushy. You'd probably sink, but you might be able to. All right, as we look at the picture, you can see where the moon and the sun is. That's where you've got most of your gravity. That's pulling your tides. So that's going to be your high tides. On the opposite sides of the Earth, you're not getting as much pull. It's kind of like stretching out a rubber band. So those are your low tides. And we're going to talk a little bit more about that. But again, you can see the sun and the moon on the right and the left. They're pulling the water towards them with their gravity. So the water's stretching out further. And as it stretches, it kind of pulls the low tides toward the Earth. Again, think about stretching out a rubber band. All right, a tidal range is the difference in the sea level between the high and the low tide. So if we looked at and measured where the low tide was in the morning, and then in the afternoon when we got to high tide and we measured that, how far it came up on the shore, the difference difference between those is our tidal range. That's like saying maybe the highest score on the test was a 90 in all my classes, okay? And the lowest score was an 80, so our range would only be 10, from 80 to 90. Okay, so the difference in the high and the low is called our tidal range. And that again changes too, depending on where the moon is and how much the gravity is pulling. All right, so we know we have 4 tides every day. We have 2 highs and 2 lows in most places. But we also have some special tides every month. Okay, so we know that the neap tides are one of them. And the other one's going to be called the spring tide, not because it happens in the spring. I think of it as a spring tide because it stretches way far out. So a neap tide is the first one that we're going to talk about. It's when the sun, the earth, and the moon create a right angle. So if you look back at your charts when we talked about moons, you know that the first and the third quarter is when we have the right angle. So we'd have sun, then the earth would be in the middle, and the moon would either be straight up or straight down. So we get a right angle. Okay? There are 2 neap tides every lunar cycle because, again, there's the first and third quarter. If you think about it, the sun would be, we'll say, on the left. Okay, and the moon might be at the top. So they're not pulling together. They're almost kind of fighting each other. The moon is trying to pull up while the sun is trying to pull to the left to pull to him. So neither one of them is winning. So nobody gets a really big tide on a neap tide. It actually has the lowest high tides and the highest low tides. I know that sounds really crazy, but it's really a small tidal range, which means there's not much difference. Instead of a high tide going way up the beach, it only goes a little way. And instead of a low tide going way down on the beach, it goes up a little higher. So there's not a big difference in the tides. Again, it's because that sun and moon are kind of fighting each other and they can't work together to pull it way up or to leave it way down. So this is a good illustration. Our sun is over on the left, like we just talked about. Our moon is either in a first or third quarter. Okay, so you can see where our low tide would be. Again, our high tide is where the moon is because the moon is closer and it's pulling a little bit more than the sun because it's closer, has a little more gravity. So it gets to pull up to the high tide, but again, because it's not working with the sun, it can't pull it up super high because while it's trying to pull up and down, the sun is trying to pull back and forth. So we get a low tidal range. You can see it doesn't look really different around it. So a spring tide is a little bit different. That's when we have the sun and then the earth and then the moon. So the sun might be on the left side pulling as hard as it can. The moon's on the right side pulling as hard as it can. So they're kind of working together to pull the water as high on the beach as it can. So they're in a straight line. They're working together. The gravitational pull of the moon and the sun add up to have a greater effect on the tides. Again, when you work together with somebody, you can get more work done. These happen during a full and a new moon because we know when they're lined up, okay? We know when they're lined up, we're either at a full or a new moon. The spring tides create the highest high tides, again, because they're working together to pull it as high as they can, and the lowest low tides, okay? Because when they're working to pull it as high as they can, when it's on the opposite side, they've pulled it so tight that there's not much water on the other side. So we have a big tidal range, okay? So that would be like if my highest score was 100 and my lowest score was a 70, we'd have a 30-point tidal range. We'd have a big tidal range. All right, so here's a good illustration. We have the sun and the moon, or we have the sun, the earth, and the moon. So again, they're working together, and you can see how when they work together, they can create this big high tide. It's pulling way out. And because it's pulling out, there's not much water left on the top and the bottom. So you have really, really low tides and really, really high tides. So to wrap it up, you can see our spring tides, or when we have our big tidal bulge, they're working together. They're pulling the water way out on the sides. Okay, and our neap tides are on the first and third quarter. They are not working together, so nobody gets to pull the water super high.